Something we like to do with plane curves is to calculate their arc length. And now we want to do the same thing with curves in space. So recall that the arc length in the plane we find by integrating from a to b, if we have a parameterization of a curve, square root dx over dt squared plus dy over dt squared dt. And in three-dimensional space, what we're going to do is just add a dz over dt, or sorry, dz over dt squared to this formula. And using our notation for vector derivatives, so if our curve is r of t, this is integral from a to b of the length of r prime of t dt. Let me just write this out. So definition, if r of t is a curve, the garbage truck is here again, in space, then its length from t equals a to t equals b is integral a to b length r prime of t dt. So let's see some examples. For example, let's consider the curve r of t is cos 2ti plus sine 2tj plus t over 8k. So that'll be the following helix. Now let's find its tangent vector or velocity vector at any given point in time. So this will be -2 sine 2ti plus 2 cos 2tj plus 1 over 8k. And so this is what the velocity vector will look like. Now, to find the arc length, or the curve length, we'll take the magnitude of the velocity. This is root 4 sine squared plus 4 cos squared plus 1 over 8 squared. And of course, sine squared plus cos squared is 1, so this is root 4 plus 1 over 8 squared. If you wanted, you could rewrite that as root 33 over 8. And so now the arc length from point A to point B, or let's do it in this case from 0 to 2 pi, which is as much as I've plotted out there. This will be integral from 0 to 2 pi of, magnitude r prime of t dt is integral 2 pi 0 root 33 over 8 dt equals pi root 33 over 4 is the length. Next, let's try a more complicated curve. So I'll take r of t is t cos t I minus 2 root 2 over 3 t to the 3 over 2 j, and then plus t sine of t times k. So that'll give us this interesting curve. Now, to find its velocity or tangent vector, we'll have to use the product rule. So here we'll get cos t minus t sine of t I minus, this will be root 2, root t, j, and then product rule again, sine of t plus t cosine of t times k. So here's that tangent vector. Now to find the magnitude, this will be square root of, and we hope that when we square these, there'll be some simplification. So this will be cos squared t minus 2 cos t sine t, or 2t cos t sine t plus t squared sine squared of t. And then when we do that to this term, we get sine squared of t plus t squared cos squared of t, and then a plus 2 term that'll cancel out this one, plus 2t cos t sine t. And now cos squared plus sine squared is 1. So we get, so this term will become 1 plus t squared, and then root 2t squared will be plus 2t. But this, we sort of got lucky and got a nice expression under the radical. So this is t plus 1 squared. So the magnitude of the velocity vector will always be t plus 1. So now, let's say we want to find the length from, let's say, 0 to pi of this, or prime of t dt. This is integral 0 to pi t plus 1 dt is 1/2 t squared plus t at pi and at 0. So this will be 1/2 pi squared plus pi. Finally, let's do an example. R of t is e to the t I plus e to the t sine of t j plus e to the t cos t k. So that's what this will look like. Now we go about finding its tangent vector. So this will be e to the t I plus e to the t sine t plus e to the t cos t j plus e to the t, we'll just group it, cos t minus sine of t k. So here's that tangent vector. Now to find the magnitude of this, well, we're going to be able to pull out a t from everything. And so now we'll have 1 plus, so here we'll get sine squared plus cos squared plus 2 sine cos. And here we'll get sine squared plus cos squared minus 2 sine cos. So these will cancel out. These will become 1 and 1. So the length at any point in time will just be root 3 e to the t over 2. Now we let's integrate that from, let's say, 0 to ln of 3. So root 3 e to the t over 2 dt. This will be 2 root 3 e to the t over 2 ln of 3 and 0. So that's 2 root 3 e to the 3 over 2, or sorry, that is root 3 minus 1. And I guess that becomes 6 minus 2 root 3 is another way of writing that.